Okay, let's look at this problem together. So an actuary is studying the prevalence of 3 health risk factors, denoted A, B, and C, within a population of women. For each of these 3 factors, the probability is 0.1 that a woman in the population has only this risk factor and no others. For any 2 of the other 3 factors, the probability is 0.12 that she has exactly these 2 risk factors and not the other. And the probability that a woman has all 3 factors, given that she has A and B, is 1/3. And we wanted to calculate the probability that a woman has none of the risk factors, given that she does not have A. And that is a lot of information. So let's use one of our organizational skills. I think a Venn diagram will be nice. That will help us sort all of the information. All right, so let's make one for A, one for B, one for C. Okay, now let's go back and read what it says. It says, for each of these 3 factors, the probability is 0.1 that a woman has only this risk factor and no others. So that's just this piece of, it's 0.1 on all of these of my circles, not in any of the intersections. For any 2 of the 3, so any pair, AB, AC, BC, the probability is 0.12 that she has exactly these 2 and not the other. So that's the stuff that's in these little footballish looking pieces right there. And we don't know what all 3 are. So we're going to label that X. So the probability that the woman has all 3, given that she has A and B, is 1/3. So let's write what those words are. So the probability that she has all 3, A intersect B intersect C, given that she has A and B, so given probability, let me rewrite that. Probability of A intersect B intersect C, given A intersect B. That is equal to 1/3. Okay, now what are we asked to find? Calculate the probability the woman has none of these risk factors. So we could say A union B union C complement. We'll do that. Given that she does not have A. So this is what we are in search of. That's a little bit better. All right, let's break down our definitions of conditional probability. So we know that this given this is equal to the probability of their intersection. So A intersect B intersect C intersect A intersect B divided by the probability of A intersect B. We know that's equal to 1/3. Now, this stuff in the middle right here is just, so A intersect B intersect C intersect A intersect B is still just A intersect B intersect C, right? We didn't get any more or less when we intersected it with A and B. That's equal to 1/3. So this is the thing that we have labeled as X. And so we have X over the probability of A intersect X. That's this whole football right here. Sorry, A intersect B, which is 0.12 plus X. And that is equal to 1/3. So we do have enough information to solve for X. We get X is equal to 1/3. 0.12 plus X. Let's get rid of that third. Multiply everything by 3. So 3X equals 0.12 plus X. 2X equals 0.12. X equals 0.06. All right. So we have lots of information. We have everything we need. So this A union B union C complement is the stuff that sits outside, right? That no risk factors at all. So what we're looking for is the intersection of these 2, right? Which is still just intersecting with not A doesn't bring any new stuff. So it's the probability of the complement of the union divided by the probability of not A. And that is what we're looking for. Well, first let's note what A is. So the probability of A is 0.1 plus 0.12 twice, so 0.24, plus that x, which we found to be 0.06. So the probability of A is 0.4. This means the probability of A complement is 1 minus 0.14 or 0.6. All right, so I know my denominator here is 0.6. All right, and the stuff outside, well, we know what the union is, the probability of the union. We add up all these disjoint pieces. We have 3.1s, 3.12s, and 1.06. So what's that? 0.3 plus 0.36 plus 0.06. So 0.36 plus 0.36, which is what? 0.72? 0.72. So the complement of that, A union B union C complement, which is our y in our Venn diagram over here, is 1 minus 0.72 or 0.28. And that's all we need to finish this problem. So 0.28 divided by 0.6 is about 0.46 repeating. So we'll say 0.467. Woo!